So this is the rough draft of some coding I did for a heat transfer project involving thermal distribution through the clutch pad of a disc brake with slip times of 0.2, 0.4, 0.6, and 0.8 seconds with a time step of 5 thousandths. This first section of code actually creates the structure of the output, which you'll see the product of that after I run the code. Following that are just material properties, things like that, that gauge and dictate how the heat transfers from the brake itself to the clutch plate, according to this equation. So with this being the rough draft, it's very bulky and it's very inefficient. This section just sets up dimensioning of the plate. They're very wide flat nodes for the mesh that is created. And with an ambient temperature of 25 degrees Celsius, you can see that I actually had to create variables for each one of the nodes within the mesh, and it's a 5 by 8. Most of the actual computation is done in these 80 lines of code because since I had to do energy balance equations for each one of the variables, as you can see, there are plenty of rows and plenty of variables and things that are deciding the final temperatures of each one of these nodes with each time step. So it's really ineffective, and I have updated code that is much more efficient and runs much better, but we'll run it anyways. So you can see it gives 3D real-time representation of the thermal distribution through this plate with these bar graphs, and then at the end of each trial it provides the maximum temperature difference throughout the plate. Now that doesn't actually occur at the end, that occurs where you can see this bar was just way up here. But it's just not very effective. The updated code actually has markers to find where this temperature is, or this temperature difference rather, is along this curve, and these curves are just the temperature difference through the plate with respect to time with each time step. So while I'm proud of the code, it's not the most effective version of that code, and furthermore I actually missed a variable somewhere in the equation dictating the temperature profile of the top corner node, which is why this bar is so low, because the flux actually is radius and time dependent, and should, this is the line for the flux, had the code been accurate, that last bar would have been even higher than the one directly adjacent to it. So there are just some shortcomings in the code which thankfully were rectified with the final iteration of the code. Furthermore, the updated code was able to condense these 80 lines worth of calculation into about 9, just the way it structured the information, and I'll post a video about that code shortly after this.